Hello, welcome. In this video, we will present the Knuth-Morris-Pratt algorithm. It is known as the KMP stream matching algorithm. In the previous two videos, we introduced the brute force algorithm and the Boy-Moore algorithm. Now, the brute force is you're going to slide only one position for the pattern to compare with the text. The Boy-Moore algorithm allows you to slide more positions, therefore it's more efficient. But in the worst case, it is still out of m times n time algorithm. So the problem with this, the Boy-Moore, is that the mismatches, if you have mismatches, and if you have successful matches, okay, if you have successful matches and the information for the successful matches are not retained. So if we can retain the successful matches from the previous attempt, and we can improve the algorithm. So that's the idea of the KMP. It takes consideration of successful matches to find the maximum number of positions to shift. So for this KMP algorithm, we're going to define a failure function. So we're going to call this as fail K as the length of the longest prefix of pattern, that is suffix of this pattern is here K, from 1 to K. The failure function can be pre-computed. So for example, so this is my, here's the pattern. And what is the failure function for this? Well, this is 0. And let's look at this A right here. This from here, 0 to 3 here. So this is a 1. Why it's 1 here? It's the prefix and the suffix right here. It's 1. So here AB, that's 2. There's 2 here. So C is 3. So there's 3 here. So that's this. Fail X is. So we're going to look at how we're going to slide the pattern. So here we have the text right here. And so we'll compare everything here. So this, it's A is match, B is match, here C, A, C. Now this A here doesn't match. All right, how are we going to slide it? We take consideration of all these matches already. So when we slide it, so we're going to come down to this right here. To do a shift here, we know this is right here and this one here. And so they match here. So this is already a successful match. So this is 3 already here. So we're going to shift 3. And then we don't have to do compare of this. We know this is already matched. So we're going to start from this A. And now here, and they don't match. And now we're going to go shift. This is actually going to 1 A right here, because this is the fail is value is 1. So that's the idea for this. And we can actually compute all this, pre-compute the fail function. And when you do this pattern matching using KMP algorithm, every time you make one comparison, and so you're going to move one position, you're going to move one position, one comparison. So all this is, there's index here. So this is I, and this is the, and this is here, it moves. So the total, it's the time complexity, it's going to be order of n times m. So the reason we can do this, it's in any case, we have either I is moved forward one position on the text, or the pattern is shifted at least one position to the right. So that is, you're going to get eventually and get the order of n times m time. So there's a more detailed information you can study here for this algorithm. So this is the how you're going to shift it, and this is the KMP algorithm here. So you pre-compute the failure function. You're going to start from this with I is 0 here, and for the text, and k is 0, and this is the pattern. So you're going to have this compare text I with pattern k. So you look at all the cases, you're going to move forward and pattern shift. So move or shift, move or shift. So that's everything you do is move and shift. So that's, you never go back. Okay, so all forward. So that's all the linear time. So that is what we have here. It's order of n plus m time. That is all for this final section in this chapter. See you on the next video.